forget to include the electron C model as well. Okay, so the electron C model is formed due to the delocalization of the valence electron for the metal atom. Okay, all right. Okay, now let's look at the physical properties of metals. So we know that metal has high melting points and boiling point. Okay, this is due to the strong attraction between the metal ions, the metal cation ions, and the delocalized electron. So it is the reason it is high because more energy is needed in order to overcome. Okay, in order to overcome the attraction and to melt or to boil a metal. Okay, all right. So that is the reason why metallic element atau compound having high melting point and boiling point. And then metal also malleable. Okay, malleable means it can be flattened or hammered into sheets. Malleable also mean kelenturan. Okay, so it is easy to lentur again due to the delocalization of electron. The electrons are mobile. Okay, and it is also ductile, which it can be drawn into wires. Okay, due to the ability of the atom to roll over each other into new position without breaking the metallic bond. Then again, it's because of the C of electrons. Okay, the attraction between the cation dengan valence electron tu can be maintained. Okay, due to the other C of electron tu. The valence electrons are mobile. Dia boleh sentiasa bergerak. So because of dia flexible. Okay, therefore the metal tu boleh dilenturkan, okay, dibentukkan into wires. Okay, and then lastly, metal conduct heat and electricity. Okay, so this is known because due to the delocalization of the electron. Okay, so the delocalized electron that can move freely within a metal structure when an electrical current is applied. Right. So factors affecting strength of metallic bonds. So we have three factors. First is the first one is ionic size or ionic radius. Then next we have ionic charge. Last but not least will be number of valence electrons. Okay, all right. So you should know that the trend across the period, generally the strength increases across the period due to the decreasing in atomic size and the increasing number of valence electron. Okay, the strength as we go across the period, the strength increases, and the metallic bonding become even stronger. Okay, this is because due to the decreasing in atomic size, we know that as we go across the period, the size become decreased, and the increasing number of valence electron. Okay, group 1, group 2, group 3, but we are talking about metallic bond kan? We are more on group 1 and group 2, and then and also some of the transition metal. Okay, all right. So this results in stronger attraction. Okay, so as we go across the period, not only the valence electron increases, the Z also increases. Betul tak? Z, dia punya charge of the nucleus also increases. Okay, so you have very positive cation, very positive nucleus, and also valence electron increases kan? So the valence electrons will become more electron means more negative lah. Okay, so it is so opposite that it creates a stronger attraction. Okay, right. Example, melting point of group 2 elements is higher than group 1. Okay, due to this reason just now. And then going down the group, okay, generally the strength decreases down the group because kenapa? The atomic radii increases. ionic charge stay constant, but charge density decreases. Okay, this result in weaker attraction among the metal ions, and melting point therefore decreases down the group. Okay, all right. So for this time around, as we go down the group, the charge remain the same. Let's say group 1, group 2. Okay, let's say group 2. Okay, as we go down the group, the charge will remain the same, positive 2 kan. But the number of valence electron is also the same. It's just that the size now will become larger. Okay, so meaning that the distance from the nucleus, the nucleus is now further away from the valence electron. So by right, the attraction is weaker. Okay, so this cause a melting point decreases down the group. Okay, so we have a knot here. Charge density is the ratio between ionic charge and radius. Ratio of the ionic charge and the radius. Okay, all right. Yes, this is the trend of strength of metallic bond across the period. It is increases, down the group it is decreases. Okay, make sure that you know reason of it being so. Okay. Example, arrange the following element according to decreasing metallic bond strength. Justify your answer by using the factors that affect the strength of metallic bond. So we have aluminium, sodium, magnesium. Identify whether these three come from the same period. They come from the same period. Yes, they come from the same period. Okay, Al come from group 13, sodium group 1, magnesium group 2. So these three having different ionic charge, positive 1, positive 2. Okay, alright. So dia punya charge tu dah berbeza. So this is the most obvious one lah, the power of the nucleus. Okay, the power of the nucleus itself. So the strongest would be aluminium lah. Okay, ni yang paling obvious, dia tak ada, ini across the period tadi ya. The charge adalah the highest, and then the number of valence electron adalah the highest also, and the paling banyak. Okay, so therefore it has the strongest metallic bond. Okay, alright. So smallest ionic radius, biggest ionic charge, and then most delocalized electron, therefore the strongest metallic strength. Okay, you can also relate in terms of the size of the ion. Okay, charge, size, charge, and then also apa lagi? Yalah, size and the charge, and also the valence electron. Okay, more valence electron. That means has most delocalized electron compared to sodium and magnesium. So this is the arrangement, okay, of the metal in terms of decreasing order of metallic strength. Okay, right. Arrange the following element according to increasing metallic bond strength. Justify your answer by using the factors that affect the strength of metallic bond. Okay, cuba try this, guys. Okay, I give you 2 minutes for this one. Okay, arrange in terms of increasing metallic bond strength. Okay, justify your answer. Arrange dulu. Okay, all right. So what is the answer? So which of these three elements has the weakest metallic bond strength in terms of
K.
its strength?
Potassium.
K.
Potassium.
Potassium. And then next,
Calcium.
Calcium.
and lastly, magnesium. Okay, all right. So the reason K being the weakest metallic bond,
It
kenapa?
has the biggest ionic radius and smallest ionic charge.
Biggest ionic radius and also
Smallest ionic charge.
yes. Okay. So K, identify whether these three come from the same period or not. So these two come from the same period. Okay, having the same N. Same M. Okay, which is N is equal to is it? No, K dengan calcium, sorry. K and calcium. This one N is equal to 3, 4. Okay, calcium is also N is equal to 4. Magnesium and belongs to N is equal to 3. Okay, alright. So kita kena compare benda yang sama dululah. Okay, alright. So N is equal to 4 dengan N is equal to 4. K dengan calcium. However, K having the weakest metallic bond. The reason being is because due to the smallest charge. Okay, kalau K dengan magnesium, kita tak boleh nak compare in terms of size lagi. Tak boleh nak compare. Boleh. Sebab dia ionic size across the period kan. So K having the largest in size, and then not only that, the charge
Smallest ionic
also.
charge.
The ionic charge is also the smallest. Okay, and then the number of valence electron, the number of delocalized electron is also the smallest, which is one electron saja. Okay, whereas calcium has smaller size compared to potassium. Okay, and then the charge is larger, the ionic charge is larger, which is +2. Tadi potassium +1. Okay, +1. This one dia +2. So the charge is already is larger than K plus, then potassium, and then size juga. Okay, calcium has smaller size, higher charge, and more delocalized electron. Okay, higher charge, higher ionic charge, smaller size, then K, and then more delocalized valence electron compared to potassium. Okay, alright. So magnesium ni kenapa yang dia adalah the strongest? Because dia yang paling kecil between K compared to potassium and calcium, because this magnesium belongs to N is equal to 3. Okay, the size is smaller. Okay, in terms of ionic charge, dia sama je dengan calcium. Okay, this time dia going down the group. Kita punya trend tu going down the group. Magnesium the strongest because it has the the size is smaller lah. Okay, the size is smaller. So that's the reason. Because charge dia sama. Okay, charge dia sama je. Valence electron pun sama dengan calcium. So the reason yang contribute, dia yang paling strongest would be the size. Okay. So kita ada K, calcium and magnesium. Okay, so these are the answers. Okay, the justification for K plus, magnesium 2 plus, and Ca2 plus. The smallest ionic radius. That will be the highlight of it for magnesium. Okay. All right. Then, okay, so these are the references in case you are interested in to know the the name of the reference book. Okay, you may look for this reference book. Okay, Ebbing, Raymond Chang, Nivaldo, Jethro, and also Tan Yin Tun, Chemistry for Matriculation Semester 1, 5th edition. Okay. Alright, Alhamdulillah, finally we are done with topic 3. Okay, silalah bernafas 5 kali untuk kita masuk ke topik 4. Right? Okay. Saya dengan ini close. Okay. Alhamdulillah. Okay, alright, so let's begin. Topic 4, state of matter. Okay, alright, so these are the content for topic 4. So we have gas laws. Okay, so I believe that you have been introduced to gas laws in your SPM time. Okay, so gas laws like Charles law, Boyle's law, Avogadro's law. Okay, so those are considered the basic of gas laws lah, before we could derive those law into the ideal gas equation. Okay, and then we have Dalton's law. So Dalton's law describe the mixture of gases. Okay, and then we have kinetic molecular theory of gases, Graham's laws and its application, real gases, deviation from ideal behavior, and last but not least, just a small portion of liquid subtopic. Okay, all right. So as you can see, most of the content describes on the gas properties. Okay, all right. So earlier on, topic 1, kita punya coverage is more on solid, okay, solid and also solution. Okay, right. For state of matter, we have the focus is more on gases. Okay, it's more on gases. Later you will have stoichiometry and whatnot, sama saja, exactly the same as what you have learned in for the stoichiometry in topic 1, sama saja. It's just that it involves gas. That's all. Okay, it involves gas, and then it can also the reaction can also involve solid, gas, and also solution. Okay, for the stoichiometry part. Regardless, what you need is the mole. Okay, in order to connect them in a equation, okay, you need the mole. The least is the mole, so that itulah kita boleh tahu dia punya relationship. Okay, alright. Okay, so let's start with 4.1 gas laws. Rasanya boleh pergi laju kot for 4.1 ni, okay? Alright, students should be able to describe Boyle's law, Charles' law, and Avogadro's law and solve quantitative problem using the respective gas law. Kita dah start untuk calculation. Okay, kita come back to calculation. Kita dah tinggal lama for the calculation. Alright, so calculation, saya punya sensitivity is the unit. Okay, so please take note on that. I am very, very sensitive with the unit. So, tolong include unit for all your calculation. Bukan unit dekat bawah tu, bukan unit for the final answer. I'm talking about unit during the process in your working solution before you calculate for the final answer. Okay, alright. Okay, gas laws. The gas law describes the physical behavior of gases in terms of 4 variables. Okay, we describe gas in terms of 4 variables. Okay, we have pressure, we have temperature, we have volume, and also amount. So in this, amount means the number of mole. Okay, we represent amount for gas as number of mole rather than mass. Okay, boleh represent mass, tapi kita use the relationship with other variable as moles, okay, which can be represented as N. So these are 3 bases of a more general law of gas. Okay, we have Boyle's law, Charles' law, Avogadro's law, and then later on we will combine these 3 laws, okay, and we name it as combined gas laws. And then later, okay, we have an ideal gas equation. Okay, right. Unit and conversion. So you should know that the most important variable to describe gas is pressure. Okay, pressure, because gas is not, most of the time gas is not visible to our naked eyes. Okay, dia tambah lagi kalau there's no color, okay, bukan colored gas, lagilah kita tak nampak. Okay, but gas tu ada, dia present. Okay, so gas ni dia create pressures. Macam mana, how does gas molecule create pressures? Due to the collision of the gas molecule with the container, the wall of the container, and also among themselves. When they collide, okay, it create pressure. Okay, pressure tu yang lagi kuat dia collide, lagi significant the pressure will be. Okay, alright. Letupan tu is because of the pressure. Okay, because dia punya reaction is very very strong. I mean dia punya it creates a very significant amount of pressure. Okay, the collision tu terlampau kuat dan menghasilkan pressure. Okay, so those are just example lah. Okay, so you need to know the unit of pressure. So to represent pressure, we have several units. Okay, the most common one is ATM, atmospheric pressure. Okay, we also have torr. Okay, so the pressure can be measured in terms of torr, and then in terms of millimeter mercury. Hg stand for mercury, and we have PA, Pascal. Okay, all right. So you should know the conversion of this unit. Take for example, if 1 ATM, it is equal to 760 torr and also 760 mmHg. 1 torr is equal to 1.3158 times 10 to the power of -3. Ataupun in Pascal, this is the value. Okay, same goes to 1 mmHg. Basically 1 mmHg and 1 torr, they are the conversion to ATM and Pascal are the same. Okay, alright. Pascal to ATM, ni value. This is very rare lah, kita jarang guna ni. Normally, we have ATM, torr and mmHg. Okay, unless question dia specify lah. Okay, so these therefore could be your dimensional analysis conversion factor. Okay, alright. So 1 ATM is equal to 760 torr. Okay, we also have 1 ATM is equal to 700 mmHg. Okay, 1 mmHg is also equal to 1.3158 times 10 to the power of -3 ATM. So in terms of Pascal also, so this can become our conversion factor. Okay, alright. So normally, most common one, if later we will be using the ideal gas equation, okay, the unit need to be in ATM. So first you have to check in terms of the unit of the pressure, because you have to convert everything, all the pressure unit into ATM. Okay. So tu kita tengok later lah. And then temperature, okay, for temperature, again later on for the ideal gas equation, you have to convert into Kelvin. Okay, you kena convert into Kelvin. So 0 degrees Celsius is equal to 273 Kelvin. So don't forget, kalau you nak nak convert into Kelvin, okay, you have to tambah the degree Celsius with the 273 in order to convert into Kelvin. Okay, and then the volume. So like I said last time, ingat ini saja, 1 mil is equal to mil is equal to cm3. Okay, 1 dm3 is equal to 1 liter. Okay, so the rest tu dia just conversion lah, just conversion saja. Kalau you dah tahu cm3 nak convert kepada liter, maksudnya 1 mil sama lah macam mil you convert into liter. Okay, cuma kat sini lah maybe you kena ingat sikit. 1 meter cube is equal to 1000 liter. Okay. Okay, alright, so let's have Boyle's law. So Boyle's law state that at constant temperature, okay, at constant temperature, the volume occupied by a fixed amount of gas is inversely proportional to the external pressure. Fixed amount of gas meaning that the N is constant as well. Okay, the temperature is constant and also the N is also constant. So if these two are constant, we can see the relationship between P and V. Okay, the volume is inversely proportional to the external pressure. Okay, alright, they mentioned dekat sini external pressure. That meaning that we will have two pressure. We have external pressure luaran and also internal pressure. Internal pressure is the pressure created by the molecule. External pressure maksudnya pressure luaran lah. Okay, sama ada kita tekan dia ke, kita give extra pressure ke, ataupun pressure from outside external lah kan. Internal means the pressure that come from the molecule itself. Okay, ataupun from the reaction itself. Okay, so this is the relationship. V is inversely proportional to V. Okay, so kalau kita nak jadikan dia sama dengan, okay, kita kena add in constant. Okay, alright, naik ke atas ni, so kita dapat constant lah, PV. Okay, so this is at condition 1 as long as dia punya temperature is the same and N is constant. Okay, alright, kita boleh vary. So P1, V1, condition 1. Okay, and then we have also P2, V2 is also constant. Betul tak? As long as T and N are constant. Therefore, kita boleh dapat begini. Because they both, okay, are equal to constant. So kita boleh P1, V1 is equal to P2, V2. Okay? Alright, so kita boleh carilah any, katakanlah dia nak tanya V ke, P ke, because we have this relationship. Alright, so this is the graph, okay, because it is inversely proportional. If P versus V, so you will get a curve dekat sini. Curve dekat situ menunjukkan, nampak tak? Kalau P, Y axis kan, kalau 0.6 atm, okay, 0.6 atm, the volume is 2 liter. If 0.3 atm, which is lower than 0.6 atm, nampak tak dia punya volume is now increases. Okay, dia inversely proportional. So that's why dia dapat curve. Okay, but normally kita akan, kalau nak mathematically solvable, okay, usually we transform the graph into a linear graph. So in order to do that, you kena buat 1 per V lah instead of P versus V. It should be P versus 1 over V, then baru you dapat straight line dekat situ. Okay, sebab curve ni normally kita akan transform into straight line. So you kena tahu how to transform this graph into a linear graph. So it should be P versus V. Okay, alright. So ini pun kena tahu the properties of Boyle's law. Sebab last time we this kind of question involving graph, okay, we have asked student to identify which of these graph represents Charles' law. You kena pilih lah. Okay, so you kena ingat, bukan just hafal benda ni, you kena ingat. And then dia display campuran. Ada yang macam ni, ada yang linear. Make sure yang mana is the most accurate, the correct one lah. Okay, the correct graph to represent Charles' law, for example. Okay, alright. So we have Boyle experiment, the relationship between volume and pressure of a gas. Okay, so Boyle investigate gases in a J-shaped tube. Okay, so initially A. Alright, so nampak tak, this is the gas sample, trap air, okay. So initially the volume is 20 ml because this is the amount of mercury present in the J tube. Okay, alright. So the delta H, the bezel, okay, the difference between this right here dengan yang dekat atas ni, the delta H is 20 mm. Gap dia dekat sini Okay, so we can calculate for the P total, dia punya calculation dia P ATM plus dengan delta H, we can get the external pressure exerted by this mercury. Okay, nampak tak 780 torr. Okay, cuba try another experiment. Experiment B, kita tambah lagi mercury. This is what we call external pressure. Kita tambah mercury. And then what happened to the volume of the gas trap just now? Nampak tak? Dia decreasing. Okay, so the value, the P total ataupun yes, the P total, the pressure, the total of the pressure now is 1560 because this gap, okay, between this end dengan the other end is 800 mm, 800 millimeter. Okay, alright. So millimeter is also torr lah. Okay, so 760 torr, which is the ATM, satu ATM kan sama dengan 760 torr, tambah dengan 800 torr is equal to this value. Nampak tak dia increasing? Okay, the total pressure is increased, but what happened to the volume? The volume decrease. Okay, to experiment Boyle's. He determined that volume was inversely proportional to pressure, so P gas times V gas is equal to K constant, right? Okay. So this is in terms of molecular view. Okay, pressure is caused by the molecule striking the sides of the container. When you decrease the volume, okay, you decrease the volume by increase the pressure. Okay, by increasing the pressure, the container will, with the same number of molecule in the container, more molecule will hit the wall at the same instant. Thus increase the pressure. Okay, increase the internal pressure, guys. Okay, increase the internal pressure. Okay, cuba tengok dia punya apa nama tu diagram that we have here. Okay, so this is before and after. Okay, alright. Initially, if we this is the imagine this is the external pressure. Okay, kita letak pemberat, kita letak weight dekat situ. Okay, this is only 1 kilogram. So the space that the molecule have is larger. Sebab dia punya external pressure dia rendah. Okay, alright. So dia rendah. So dia ada more space to move around, to collide with the with themselves and also to collide with the wall of the container. Okay, alright. Imagine if we increase the external pressure, maksudnya kita tambahkan pemberat tu, becomes 2.5. So dia push down, okay? Imagine it's like a piston, so dia push down, and this cause the volume to decrease. Betul tak? The volume is now decreased, and what happened to the region ataupun to the space of molecules in the container? The space become smaller dekat situ, tapi amount of molecule tu sama. It's just that the space is now smaller. Okay, therefore the molecules tu dia kurang space to kurang space to collide. Molecule tu have higher tendency to collide with the same same spot in the container. Okay, so pelanggaran tu jadi lebih aktif dekat situ. Okay, therefore more pressure will be produced. So in terms of internal pressure, the internal pressure will increase. Faham tak? Okay, hope you guys understand. So nampak tak dia increase in terms of dia punya gauge dia dekat sini, so dia increase. Sebab apa? Bila space dah kurang, pelanggaran akan lagi jadi lebih banyak sebab space dah kurang, so dia akan tend to langgar lebih frequent. Alright, so please don't get confused with external pressure, internal pressure, these two. Okay, external pressure tu apa, internal pressure tu apa. Okay, Sebab dia cerita P external dengan V. Bila P external increases, V will decrease. Okay, tapi dia tak cerita internal. What will happen to the internal pressure? The internal pressure will increase. Tu jawapan dia. Okay, this is in terms of molecular volume. So does increase the pressure. Ini tambah kat situ. This is P internal. Okay. Alright, so air trapped in a J tube occupies 24.8 mil at 1.12 atm. So this is the pressure, this is the volume. By adding mercury to the tube, the pressure on the trapped air increased to 2.64 atm. So this is the P2, this is P1. Okay, assume constant temperature, determine the new volume of air in liter. Okay, so we have P and V, therefore we're going to be using the Boyle's law. Okay, so kita pakai P1, V1, P2, V2. Okay, alright, so kita pun nak cari siapa, kita nak cari apa? By adding, determine the new volume, dia nak the new volume. Okay, so it will be V2 lah. Okay, V for this pressure. So masukkan all the infos and then calculate, it will be 0.01 liter. Okay, don't forget the unit ATM. ATM cancel, that's why we have liter as your final unit. That's true. Okay, alright, checkpoint. Okay guys, buat saya bagi 3 minit untuk you guys complete this checkpoint. Okay, sedap sikit lah, dia ada banyak apa nama tu, banyak exercises, banyak checkpoint so that you tak boring dekat situ. Okay. Okay, jom. A gas occupying a volume of 725 ml at a pressure of 0.97 atm is allowed to expand at constant temperature until its pressure reaches 0.541 atm. Calculate the final volume. Okay. Alright. So while we are still on the topic of Boyle's law, okay. So kita of course lah pakai Boyle's law. Okay. P1 V1, P2 V2. So this is the answer. Okay, all right. So moving on to Charles' law. So Charles' law pula, at constant pressure, the volume occupied by a fixed amount of gas is directly, volume again, is directly proportional to its absolute temperature in Kelvin. So V is directly proportional to T Alright, so kita nak make this thing solvable, nak selesaikan dia, nak mudahkan dia. So V over T is equal to a constant. Okay, alright, so V1, T1, condition pertama is equal to constant. Condition kedua is also equal to constant as long as the pressure and also the N remain the same. Therefore, it should be constant lah. Okay, if any of these two is altered, okay, automatic dia tak jadi constant lah. Right, so therefore kita boleh equation 1 sama dengan equation 2. So kita dapat this relationship. Okay, alright, so at fixed P and N, V decreases as T decreases. So they directly proportional lah. V increases, T increases. Okay, V decreases, that means T decreases. T decreases, V decreases. Okay. Okay, alright. So this is the graph. At volume of 0, the temperature will be negative 273 degrees Celsius, which is at absolute 0. Okay, so as you can see, as the temperature increases, untuk P1, P2, P3, P4, cuba tengok. Okay, try to look for P4 first. Okay, tengok P4. Okay, as the temperature increases, what happened to the pressure? The pressure also increases. Okay, this is condition 1. Condition 2 sama juga P3. If the temperature increases, ke kanan nampak tak? Ke kanan, the pressure also increases. So dia linear. Dia terus dapat linear guys tu. Right? Alright. Okay. This is in terms of molecular view. Okay, to understand the molecular view of Charles' law, the pressure of gas inside and outside the balloon are the same. Alright, initially, mula-mula before the pressure inside the balloon and also outside the balloon, okay, they are the same. Alright. Maksudnya kita tak ubahlah the temperature ke apa ke, dia sama. Okay. Bila kita change the temperature, we increase the temperature to a higher temperature, the gas molecule in the balloons are moving faster. Oh, this is not. Dia terus je buat eksperimen tu Okay, ni dekat high temperature lah. So when the gas molecule in the balloon is when the temperature, okay, the temperature is increased, the gas molecule in the balloon are moving faster. So they hit the side of the balloon harder, causing the larger volume. Okay, when temperature increases, the molecule is now having extra energy. They absorb the heat tau. Panas kan? So they absorb the heat. Okay, the molecule absorb the heat and now the molecule having extra energy. So bila they ada extra energy, they move faster. Bila move faster, it collides more. Bila they collides more, that means the pressure will increase there. Okay, bila they collide, they keep pushing. Gas pushing tu panggil pressure. Pressure tu alternatively people call it as gas pushing. So they push further and cause the volume to become expand. Okay, the balloon is now, the volume of the balloon become larger. Okay, that's why if you put in the boiling water, it become expand. Dia jadi lebih besar. Okay, alright. If we place the balloon in a low temperature water bath ataupun ice bath lah, for example, okay, the gas molecule in the balloon is not moving fast. Okay, so they don't hit the side of the balloon as hard. Therefore, the volume is small. So imagine it's opposite the first one just now. The molecule is now having less energy. Bila less energy, dia punya movement pun slower. Bila slower, dia collide less. Okay, bila dia collide less, dia tak push the side of the container and it cause the volume to shrink ataupun the volume become smaller. That's why lah dia kuncup je ni. Okay, so this one, molecule having higher kinetic energy due to increase in movement. Okay, increase in speed. This one lower in kinetic energy due to decrease in speed. Okay, banyak benda kita boleh relate sebab dia become faster kan. So bila something that is always on the on the move, dia become higher kinetic energy. Okay, alright. Example, tank of nitrogen occupies this volume under a pressure of 1134 torr at this temperature. Okay, calculate the volume in liters that would be occupied at this temperature if the pressure and amount of gas are kept constant. Okay, so this is between temperature and volume. So it is Charles' law. Okay, all right. So apply Charles' law. So we have two conditions there, but we can have this relationship so we can solve for the volume. Right? Okay, macam biasa kita ada checkpoint. Okay guys, please complete this checkpoint. Okay. All right, so let's look at the solution. So this is the solution for this checkpoint. Okay, it's determine the final volume of the gas. Right, so 44.1 liter. Dapat tak everybody?
Dapat.
Cuba. Ini warm up je. Bagi apa? Bagi ada pergerakan sikit lah. Jadi macam balon yang panas tu, high kinetic energy. Okay, alright, warm up je ni. Okay, jalan. Avogadro's law. Avogadro's familiar, is the same scientist yang came up with this law. Avogadro's constant last time. So this time kita ada Avogadro's law for the gas. At constant pressure, okay, this is a constant condition, pressure and temperature, volume of gas. The volume again is directly proportional to the number of gas molecules. So we represent the number of gas molecule as moles. Okay, all right. So equal volume of any gas contain equal number of molecules. So this is the relationship. In case you are not given the mole, okay, kita boleh equatekan the volume is proportional to N. V is almost the same as N. Kalaulah kita tak bagi N, kita hanya ada V saja, we can use that as our stoichiometry solution. Okay, that's why dia bagi kasi equal volume of any gas contain equal number of molecule. Okay, alright, so V is directly proportional to the number of mole. V over N is equal to constant. So therefore, this is the relationship. So at fixed pressure and temperature, the V decrease as N decreases. Okay, V increases as N increases. So directly proportional lah. So kalau kita nak represent using gas, so we got linear graph. Okay, linear graph dekat sini. Linear line dekat situ lah. So volume versus number of mole. Okay, when number of mole increase, katakanlah increase kan. So what happened to the volume? Volume 15 for example. Kalau number of mole become 1, kita increase to 1, what happened to the volume? Volume. So 23. So 15 jadi 23, kan increases tu. Okay, so dia directly proportional. Okay, molecular view again. Initially, the pressure of the gas molecule in the container equals to the atmospheric pressure, where P gas is equal to P ATM. So this is the before. Okay, this is the initial state. Initial state. Okay, di mana the pressure inside the container is the same as the pressure outside. Okay, ataupun P internal, P yang datang daripada gas is the same as the P external. In this case, ATM lah, atmospheric pressure. Pressure kita yang dekat luar is the same. Okay, sebab tidak ada movement of the of the piston. So let's assume this as piston lah. Kita tolak naik ke atas, okay? Dia boleh bergerak this slide ni. Okay, when more gas volume introduced into the container, maksudnya the volume of container. Volume of the container dia sama saja, tapi kita add in, kita masukkan more gas into the container. So what will happen? Macam ni, contohnya N increases, kita masukkan, macam nak increase the N, kita tambahkan, we add in more molecules into the container. More gas is pumped in, kita masukkan, okay, dia ada dekat sini, ada bulat ni kan, dia pump in more gas. Okay, alright, so what will happen? The frequency of collision of the gas molecule with the wall of the container has increased. Now the P gas, the internal pressure is larger than the P ATM. Okay, and the gas molecule move the piston and increase the volume until the P gas is in equilibrium with the P external, the external pressure. Okay, alright, logically speaking, the more you pump in the molecule into the same volume, by right, what will happen? Lagi banyak molecule means lagi banyak collision. Okay, more collision will take place dekat situ. So the more gas pushing dekat situ. So this will cause pressure to increase. Bila pressure increase, so dia langgar ni kan. Dia langgar sini kan, dia langgar. So this will push the piston upward, dia menolak piston tu. Okay, because the pressure in this volume is increased. Okay, in order to overcome this, dia kena tolak lah ni. Okay, so that's which later eventually the internal pressure, which is the gas pressure, will be the same as the external pressure sebab volume dah jadi lebih besar dekat situ. Okay, alright. Dia macam you ada dalam kelas lah kan, kelas yang kecil. Kelas tu muat 30 orang. Okay, tak ada kipas, tak ada aircon. And then you masukkan lagi 30 orang dalam kelas yang sama yang tak ada aircon, tak ada kipas tu. Agak-agak dia jadi lagi panas ke, jadi lagi sejuk ke, restless lah kan. Everybody become restless, macam tak selesanya, berpeluh-peluh lah apa macam tu kan. Contohnya. So pressure dekat dalam kelas tu sekarang tinggi. Okay, sebab masing-masing dah panas, masing-masing dah bengang dengan baunya, dengan meruap je dengan macam-macam lah. Okay, nak tunjukkan keadaan pada ketika tu. Kalau tak do something, kalau okay buka lah kelas ataupun buka pintu ke, tambah aircon ke supaya become selesa sikit. Kalau we subject to this content, okay, with this context, mungkin dekat situ kita boleh ada dinding yang kita boleh buka. Okay, kita boleh remove the wall so that the volume become expand lah. Okay, we have that in asasi. Okay, so antara bilik tutorial tu kita ada divider je. Kita boleh buka bilik tu supaya dia jadi lebih besar. Nanti tengoklah semester 2. Alright? Okay, right, example, a scale model of blimp rises when it is filled with helium to a volume of 55 liter. Blimp ni macam belon panas lah, tapi bukan macam belon panas tu, dia memang dah static gitu. Boleh google lah blimp tu apa Okay, dia boleh rise if it is filled with helium to a volume of 55 liter. So this is the maximum volume in order to fly the blimp, okay, to make the blimp rise. When 1.1 mole of helium is added to the blimp, the volume changes to 26.2 liter. Kalau letak 1.1, the blimp into the blimp, the volume changes to 26.2 liter. So calculate the new mass in gram of the helium gas that must be added to make the blimp rise. Okay, assume constant T and P dekat situ. Soalan tanya nak gram. Okay, alright. So before we could calculate for gram, kita kena calculate for the mole first lah. Okay, alright. So let's see. So we're going to be using this relationship. Okay, so we have the condition just now. The second condition V2 just now adalah apa? V2, okay, dia assume V2 is 55 liter, okay, yang kalau dah penuh blimp tu, yang dia boleh naik. Alright, so V1 kita adalah 26.2 liter and the mole is 1.1 mole. Okay, alright, so we can find out the the mole for 55 liter. Okay, alright, so this is the mole required in order to rise to make the blimp rise. Okay, so this is the amount of mole. Tapi soalan tanya mass of the helium that must be added. Soalan tanya tu, bukan soalan tanya berapakah mole ataupun berapakah mass for the blimp to rise. Soalan tanya berapa helium need to be added to 1.1 tadi. Berapa yang nak dikena tambah so that they rise. Okay, alright. So kita ada additional step dekat situ. So we have 2.31 is the optimum mole of helium for the helium to rise. Okay, this is the current mole of helium. Current yang ada, kita hanya ada 1.10. So how much do we need to add in? So we tolakkan, we got this one. So next kita convert this into mass. Okay, we have to multiply with molar mass. Okay, conversion factor. Okay, alright. Okay, so one question, checkpoint 3, guys. Please complete this checkpoint. Okay, right. Right, so let's look at the answer for this checkpoint 3. Okay, in this checkpoint, you are required to calculate the number of mole of gas added to the container, which is almost the same as the previous example just now. Okay, sorry. Okay, all right. So the final answer is 21.5 mole. Okay, so this is the mole added. Dapat tak, everybody?
Dapat.
Okay.
Dapat,
Good, eh?
Dapat.
Good.
Dapat.
Okay, bagus. Okay, now let's move on to combined gas law. Okay, combination of variable used in Boyle's law, Charles' law, and Avogadro's law into a relationship. So we know that Boyle's law, okay, we have PV is equal to constant, Charles' law, V over T is also equal to constant, Avogadro's law, V over N is equal to constant. Okay, all right, we can combine this, okay, into this. Kita boleh dapatkan this. Okay, after all, you nampak tak semuanya ada V dekat situ. You may rearrange this into this. V is directly proportional to NT and inversely proportional to P, or PV over NT is equal to constant. Okay, all right, so like what we have for Boyle, Charles, and Avogadro just now. Okay, if we have two conditions, we can relate them into this relationship. Okay, P1 V1 over N1 T1, this is condition 1, is equal to P2 V2 over N2 T2, condition 2, which also equal to constant. Okay, constant. Alright, example lagi dekat sini. At 24 degrees Celsius, the pressure in a cylinder containing 5 mole of oxygen gas is 5.1 atm. Calculate the number of mole of the oxygen that should be released to maintain the constant pressure when the temperature is increased to 204.5 degrees Celsius. Okay, alright. So banyak info yang you kena ada dekat dalam tu. Tapi baca betul-betul. Yang mana yang constant pressure, that means kita boleh constantkan lah the pressure. Pressure can be constant. Constant pressure kan? Dekat situ. Okay, alright. Maksudnya dia cancel out lah dekat situ. So the rest kita boleh masukkan lah all the information. P, calculate the number of mole should be released and the pressure in the cylinder containing. Sama juga. Even the cylinder also the same. Okay, dia tak mention anything about cylinder ke apa kan dekat situ kan. Tapi kita kena put something lah dekat situ. Sebab dia cancel out at the end of the day, dia jadi satu, tahu tak? Okay, dia jadi satu dekat atas tu. P dengan V dia tak bagi information. Constant and the volume is not given. So kita assume volume pun it will be the same volume lah. Okay, the pressure in a cylinder. So cylinder maksudnya cylinder yang sama tapi different condition. Initially the temperature is 24. And then what happened if it increased to 245 degrees Celsius? So pressure dengan volume dia kita consider the same. Okay, that's why dia dapat satu dekat situ. So now what we have is mole dengan temperature. So masukkan, okay, masukkan dekat dalam formula and then dapatlah dia punya final mole. K cancel out with K and then we have mole as our final unit. Okay. Okay, so we have checkpoint 4 dekat situ. Okay, kita ni saya nak proceed. Okay, alright. So all the checkpoints tu please completekan dekat homework lah, homework. Okay, so we will discuss it during our next lecture. Sebab macam dia macam nak bagi practice kan, lagi banyak practice using the combined gas law just now. Okay, alright. Maksudnya boleh terus tengok lah apa. Aerosol container often carry the warning that they should not be heated. Suppose an aerosol container will fill with a gas 4 atm and 25 degrees Celsius and may rupture if the pressure exceeds 8 atm. Determine the temperature at which the container will be ruptured. As you can see, dia bagi information on the pressure and the temperature. Okay, this is the pressure. So the rest kita boleh consider that they are all constant. Okay, they are all constant. That's why bila dekat sini you end up ada P dengan T saja. We have P and T. Okay, ini bukan, this is not Charles law. Charles law V dengan T kan. This is P dengan T. So this one kita we got from the combined gas law. Okay, with understanding that the rest of the variable, the rest of the parameters are all constant. Constant sebab yang lain tu yang P dengan T saja yang berbeza. Okay, alright. So that's why kita ada this relationship. This one come from the combined gas law, right? Nishu faham kan ya? Okay. Next, ideal gas equation, guys. Okay, this is 4.2. This is very important. We have 3 learning objectives. Make sure you cover all of this once you have completed this subtopic. Okay, alright. Ideal gas equation. An ideal gas is a gas that exhibits linear relationship among pressure, temperature, volume, and number of moles. Okay, again, ideal gas is a gas that exhibits linear relationship among pressure, temperature, volume, and number of moles. So for ideal gas, we have 2 assumptions. Okay, we assume sebab nama dia, the word ideal is there. What do you mean by ideal there? Okay, it means that we assume that the gas has no attraction or repulsion between molecules of an ideal gas. Okay, kita punya basis on this statement adalah, this reason adalah sebab gas, the molecules are far apart from each other. Dia jauh kan, compared to liquid and solid kan, they are far apart from each other. So the attraction tu more or less macam ada tak ada. Remember intermolecular forces? Okay, in order to have that intermolecular forces, the best is to get closer to one another. Tapi kalau dah terlampau jauh dekat situ, okay, so as if macam there is no attraction. Ada tapi very small attraction ataupun insignificant. Okay, it's not significant compared to liquid and solid. Okay, alright, so let's just, maksudnya in ideal gas, abaikan je lah. There is no attraction or repulsion. Okay, so bukan dia saja come out dengan that justification, is because of gas itself, the properties of gas itself, the gap between the molecules are far apart, dia jauh. Okay, so that is the justification. So assume if it's ideal, kita assume that it is ideal if there is no attraction or repulsion between molecule of an ideal gas. The ideal gas volume is negligible compared with container of the volume. So again, the gap is too far away, okay? So dia tak ada its own volume. Compared to solid, dia ada dia punya own volume, betul tak? Dia punya packing dia tu is very close to one another sampai kita boleh nampak kat dia visible lah dekat kita punya mata. Okay, normally untuk solid we go for in order to consider for the volume, kita macam mana nak kira dia punya volume, panjang darat lebar darat tinggi kan. So that is for solid. Liquid pula depends on the container that it is placed in. Okay, but tapi dia still flexible. Liquid is still flexible but it still have its own volume. But untuk gas ni, dia sebab dia punya gap tu terlampau besar, okay? So nak kira dia punya volume tu, molecule punya volume. Okay? Tak susah, tak boleh sebab dia punya gap tu terlampau besar, terlampau jarak dia tu terlampau jauh. Okay? Alright. So because of that, the gas volume, the particle volume. So that's the word. The particle volume of the gas is negligible. Kita boleh abaikan lah. Dia ada tapi insignificant. So it is negligible compared to the container volume. So that is why normally to consider for the volume of the gas, kita terus je ambil the container's volume. Okay? So, sebab kita tak boleh nak quantify due to the big gap between the molecules. Okay, right. So no ideal gas actually exists. Sebenarnya, like I said, tak wujud je gas ni. Tapi, but most simple gases like hydrogen, helium behave nearly ideally at ordinary temperatures and pressure. Okay, ideal ni adalah keadaan. Dia bukan ideal gas adalah hydrogen, adalah oksigen. No, dia adalah keadaan. Keadaan di mana these two assumption are applied. Okay, kita assume dia adalah ideal gas, tak kisahlah dia hydrogen ke helium, bila there's no attraction and the volume is negligible. Okay, so it can be helium ke, nitrogen ke, whatsoever ke. So dia boleh diconsider sebagai ideal gas. Maksudnya kita assume dia tak ada attraction and the volume is negligible. Apatah lagi for simple gas like hydrogen and helium. Okay, because they are small. Ni gas particle volume ni, particle gas for hydrogen and helium, they are small. Bila small and then attraction dia of course lah lagi lesser. Right? So that's why dia kata, but most simple gases behave nearly ideally. Maksudnya dia behave macam ini. Okay? Almost ideal at ordinary temperatures and pressure, which is maksudnya at kita punya current temperature and pressure lah, normal temperature and pressure dalam keadaan sekarang. So hydrogen, helium, simple gases, they behave almost ataupun nearly ideal. Okay? Right. Okay, so kita mengambil kira all the Boyle's law, Charles law, Avogadro's law. Okay, we have this one just now. Okay, so kita rearrange this. Okay, kita nak tukar kepada sama dengan, kita akan kena insert constant, betul tak? We have to insert constant. Okay, alright. So the constant kita represent it as, constant ni as R. Okay, so kita tak guna K lah, we use R to represent the constant. So if we rearrange this, okay, V is equal to R and T over P, we rearrange that into this, we got this, this is what we call ideal gas equation. PV is equal to nRT. Okay, PV is equal to nRT. So R is the gas constant. Okay, so the value of R, constant kan? Kena hafal lah, constant. So the value of R is 0.0821 liter ATM mole negative 1 K negative 1. So that is why I mentioned to you just now. Okay, most of the time if we are using this ideal gas equation, the pressure need to be in ATM. The temperature also need to be in Kelvin. You have to convert everything first into its unit based on the ideal gas equation. Okay, and then only you can apply the equation. Alternative to this value, we can also have this value 8.314, but as you can see the unit is now different. So madam, nak kena hafal yang mana? Depends on the question, depends on the unit given in the question. If the unit is given in terms of ATM ataupun dia bagi dalam bentuk pressure ke, dia bagi dalam bentuk pressure, that means you have to use this one. Pressure dalam tol tak ada masalah, we can convert into ATM. Because unit untuk yang kedua ni, nampak tak ada tak value ada tak unit berkenaan ataupun berkaitan ataupun related to pressure? No, we don't have. We have joule, mole dengan key. Okay, alright, so it depends on the question. Dia bagi pressure tak? Kalau dia bagi pressure, normally we will go for 0.0821. Okay? Alright, so the condition of 0 degrees Celsius and 1 ATM are called standard temperature and pressure. Remember last time, topic 1, STP, at standard temperature and pressure. So the pressure is 1 ATM, the temperature is 0 degrees Celsius. Okay? Alright, so at STP, 1 mole of an ideal gas occupies 22.4 liter. Ini pun sama, cerita lama. So 1 mole of gas, the volume is 22.4 liter. This is also what we call molar volume. Yeah, this one. This is molar volume. The volume for 1 mole of gas. Okay, alright. If we apply this condition, okay, kita masukkan all the values into PV and RT, the 0 degree Celsius, the 1 ATM, okay, and then the volume for 1 mole just now 22.4. Nampak tak bila kita masuk all of this value into the ideal gas equation? Nampak tak value dia kat sini? You dapat 0.0821. Okay, you dapat 0.0821. This is just to prove lah, nak justify the value. Where did you get the value from? Daripada yang inilah. Okay, alright. So nampak tak dia punya unit for R dekat situ is liter. Panjang sikit lah, you kena hafal lah. Liter, ATM, mol, -1, K, -1. Macam mana dia dapat? Macam ni lah. ATM, dia darab dengan ATM, liter. And then mol dekat bawah. Kelvin dekat bawah. So mana ada cancel out. So you kena carry all the unit tu throughout. Okay. So that is the unit for R. ATM, liter, mol -1, K -1. Right? Okay. Macam mana nak dapatkan 8.31 for joule, mol -1, K -1. So as you can see, okay, the P used is Pascal. Pascal, and then the volume need to be in M3 dekat situ. Okay, M3 dekat situ. These two, when you times these two, you got joule. It's equivalent to joule. Okay, so ni jarang lah kita guna 8.314 unless you are asked in the question. Okay, value of R will be used depends on the information given in the question. Okay, real gas behave like an ideal gas as an ideal gas at high temperature and low pressure. Okay, real gas adalah gas-gas kita yang ada sekarang. Oksigen, nitrogen, helium, those are called real gas. Kategori real gas lah. Gas yang betul-betul, maksudnya gas oksigen, gas yang tu real. Okay, ideal like I said is a condition yang mana dua syarat tu. Apa dua syarat tu? Dia punya intermolecular forces is not is negligible. And also dia punya volume, the particle volume is also negligible. Tu keadaan tu. Kita assume dia ideal if we don't have these two condition tadi ya. Alright. So normally real gas akan behave macam ideal, keadaan yang dua tadi yang tak ada intermolecular forces and also particle volume tadi at high temperature and low pressure. So these two conditions, please remember guys. Okay, make sure you ingat lah. Okay, they behave at high temperature and low pressure. Kenapa logically speaking adalah when we talk about high temperature, when you have high temperature, what happened to the movement of the particles? Okay, the movement of particle become very active, betul tak? Because of the kinetic energy increases. So what will happen to the gap dekat sini? Tadi yang biasa-biasa tu pun dah tak rasa the intermolecular forces. Apatah lagi at high temperature. Bila the molecule is heated ataupun having high temperature, dia movement tu become even faster. Okay? Dia punya pelanggaran tu lebih cepat, lebih banyak, lebih laju. So dia tak ada interaction. There's no interaction at all dekat situ. Sebab dia punya gap tu dah jauh satu hal. Lepas tu movement pula laju. Do you think they will have attraction between them? So lagilah tak ada. Okay, that's why lah kita kata real gas will behave as an ideal gas at high temperature. So due to that reason just now. Okay, sebab dia tak ada interaction lah because dia dah move faster. Okay, they keep on moving. Low pressure lah. Kenapa low pressure? Kenapa low pressure menyebabkan real gas ni behave sebagai ideal gas? Again, low pressure means volume dia besar. Low pressure dia inversely proportional to volume, betul tak? Kalau pressure tu rendah, maksudnya volume tu besar. Volume space become larger. Okay, the space become larger. So maknanya dekat situ dia banyak ruang untuk bergerak. Okay, dalam gapnya jauh, dia punya gap antara sesama dia tu jauh. Now space pula become larger. So imagine kalau you duduk rumah kecil dengan you duduk rumah besar. Duduk rumah kecil pun tak bertegur siapa, apatah lagi you duduk rumah besar. Ada probability tak you nak ada attraction dekat situ? So tak ada. Okay, so that is what it meant by low pressure, ataupun nak lebih nampak higher volume. Volume become larger. Okay. Okay. Yeah, that's why you kena ingat dia behave ideally or almost ideally at high temperature and low pressure. Okay, so standard condition of ideal gas STP specify a pressure of 1 atm ataupun 760 torr and a temperature of 0 degrees Celsius. Okay, ini kan dah cakap, kenapa cerita lagi? Tadi dah cerita je. Standard molar volume maksudnya the volume for one mole. It is 22.4 liter. Okay, nampak tak? We have helium, nitrogen, oxygen. If it's for 1 mole, okay, so the volume will be the same, guys. Nampak tak? Volume dia akan sama. So 1 mole of gas at this condition, at this STP condition, it will be 22.4 liter. Okay, but of course kalau in terms of mass dia berbeza lah. Mass berbeza, volume dia yang sama dengan syarat terangkat laptop. Okay, dengan syarat at STP. Okay, alright, akhirnya sampai for example. Calculate the volume in liter of carbon dioxide gas that would be formed at a temperature of 3 to 3 K if 1.19 atm of pressure is applied and 32.05 gram of solid carbon dioxide evaporates. Okay, alright. So kat sini, if you guys notice, Boyle's law, Charles' law, Avogadro's law, normally the question give us 2 condition, you guys. Okay, that's why kita ada P1 V1 is equal to P2 V2. But this time around, we don't need that condition. Okay, kita just straight away use the ideal gas equation. Sebab soalan nak tanya apa? The volume kan? So we can use PV is equal to nRT. Okay, so we want to find volume. So by right, P, N, R ni memang constant. So T, N dengan V ni should be given. Okay, so those should be given. So bolehlah kita cari. Tak perlulah condition 1, condition 2 like what we did just now. Okay, so boleh apply terus using the ideal gas equation. So nampak dekat sini you nak volume kan. So you can imagine the final unit should be liter. So ATM here will be cancelled out. Mole mana mole? Mole this one dengan mole negative 1 from the unit, from the constant will be cancelled out. K negative 1 and K here will be cancelled out. And then we are left with liter. Nampak ni dekat R tu. So we are left with liter. Okay? Alright, so make sure before you use this PV and RT, you make sure that the unit should be converted into the same unit that we have in the constant. Okay, jangan terus shock sendiri terus pakai. Volume kena tukar in liter. Kalau torr ke mmHg ke, you need to convert into atm. Temperature in degrees Celsius, you need to convert into K. Okay, prepare dulu all those things before you insert into the formula. Okay. Right, checkpoint 5. Cubalah calculate ni. Nak bagi warm up sikit dengan PV and RT. Try calculate for this one. Checkpoint 5. Lupa make sure you guys semayang dah solat belum? Yang tak solat pergi solat. Kan tak pasal-pasal saya dosa pula kan. Saya benarkan kalau untuk solat pergi sila solat. Sepatutnya sebelum kelas kena solat lah dulu Jangan kan tak pasal-pasal dosa kering. Orang panggil dosa kering. Tak mau Terima kasih banyak-banyak. Okay. Okay. Alright, jom. So this is the answer for this checkpoint. I saw kilogram. Okay, so the mass is given in terms of kilogram. So make sure you convert into gram lah. Memang lah, kita tak gram later kita nak convert for mole kan. We need to find the mole. Yep, and then prepare everything and then insert into the PV and RT. If the temperature is 25, okay, need degree Celsius, you need to convert into Kelvin. You calculate the pressure inside the tank, the pressure of the gas, okay? All right, so make sure you convert what need to be converted before you insert into the equation. All right, moving on. So we are the checkpoint 6, okay, boleh completekan this checkpoint, we will discuss next week. Okay, ada checkpoint 7 juga dekat situ. Discuss pula. Make sure to complete the checkpoint first, okay? Kita sambung next week, okay? Application of ideal gas equation. Ideal gas equation can be used to calculate molar mass dengan density. Okay, so ideal gas, maksudnya question can also ask in terms of molar mass and also density. By using the same ideal gas equation, PV is equal to nRT, we can derive it in terms of density and also molar mass. So how do we derive it in order to get the molar mass and density? Okay, all right. So molar mass. Okay, let's say we have PV is equal to nRT. Okay, in order to get molar mass, maksudnya kita kena extract from mole, betul tak? So we know that PV and RT, N is equal to mass over molar mass. Right? Ya, begitu. Tada, siap dah. Okay, you can extract out the molar mass. You can find the molar mass by using the same equation. Or alternatively, you can try to calculate the mole first and then dekat luar, externally, you can calculate for the molar mass. Okay? Because M should be given lah. Okay, of course M should be given in order to find the molar mass. So kena kembang from N into M over molar mass. Okay, and then you can find out the molar mass. Ini cara dia dah transfer to the other side lah. Okay, alright. So that's why jangan hafal. Do not memorize this equation. Apa yang you kena tahu adalah derive. You pegang satu saja and then you derive from it. So N is mass equal to molar mass. So you have your molar mass already. Okay? Alright, so that is for molar mass. Okay, soalan contoh nak calculate the molar mass. So by using the PV and RT just now, okay? Jadi extract out you derive M is equal to M over molar mass. Ataupun you can calculate externally. Calculate for N and then later you can calculate for molar mass, right? Okay. Density, yeah. Okay, density. So how do we calculate density by using PV and RT? Okay, all right. So this is PV and RT. So we know that density is equal to mass over M over volume. Betul tak? We know that density is mass over volume. Right? Okay. So we can obtain the mass from N. Betul tak? And V, we do have V in the equation. Okay? Alright. So kita kena rearrange dekat situ. Okay. Tak apa. Kita kembang dulu the N so that we get the mass. PV N kita kembang, we expand it ataupun we derive it. N is equal to M, which is the mass over volume. Bukan volume. Molar mass. Okay. RT. Okay, so now is the time for the to arrange the the variable so that we can get the density. Okay, alright. So kita pindah. So kita akan dapat P M is equal to M over V. Ni saya pindah ke sini je lah kan, betul tak? R T. Okay, dapatlah susun dia M dengan V tu, betul tak? So kita akan dapat P MM density RT. Okay, density RT, dan kita transfer to the other side, dia jadikan kepala dia. So density is equal to PMM over RT. Sama tak dengan yang saya tunjuk ni? Ni nampak? Mana ni? Ni, this one. Sama tak? Sama. So tak payah susah-susah hafal. Yang mau masa banyak lagi benda lain nak hafal. Okay, you derive sendiri on your own. Ni nak buat externally pun tak apa. It's okay. You boleh, maksudnya you calculate for the mass first and then next you calculate for the density. Di luar daripada equation. Boleh, tak ada masalah. Okay? Alright, so it's just that please be careful in terms of the unit. Okay? Yeah, calculate the density of carbon dioxide in gram per liter at 0.99 atm and 55 degree Celsius. Okay, alright. So you have to calculate the density. Okay, by using ini tak hafal tak apa. Start from the PV and RT, derive daripada situ. Okay, jangan buang masa lah nak hafal. Saya memang tak galakkan lah untuk you hafal setiap derive sendiri. Okay, and then insert. So dapatlah you punya density. So ATM cancel ATM. What else? K -1 cancel with K. And then mole, do we have mole? Yes, we do have mole -1 here. And mole -1 dekat sini. So mole -1 ni dia dah lah dekat bawah. Okay, -1 times negative, you akan dapat positive. That's why they end up cancel out. So after all, mole -1 dengan mole -1 dia cancel lah. Tak payah susah pening kat situ kan. Cancel. So you ada gram and mana liter? Ni. That's why you ada gram per liter dekat situ. Okay? Right. Alternative solution. So this is what I mentioned just now. You can calculate externally outside of the equation. Okay? So you have the density mass over volume. Boleh. Maksudnya you calculate for the volume and then later you have the density is equal to mass over volume. So you boleh juga calculate sebegini. Right? Okay, so we also have a checkpoint, okay, to apply the density and the molar mass just now. Okay? Alright, so lastly, before we end our lecture here, so this is just to introduce to you the gas stoichiometry. Okay, like I said in the earlier lecture tadi, saya ada cakap kita akan guna the stoichiometry. We cannot run away from stoichiometry lah. It's just that for gas, when it involve gas, that means it involve other variable parameters macam pressure ke whatnot. Whatever it is, what you want is the mole. Okay, what we want is the mole. So how do we extract the mole? So we can calculate for the mole using the PV and RT, and then kita buat macam biasa lah. We have the equation. Kita buat dia punya stoichiometry, relationship, product and reactant and whatnot, sama exactly as what we have learned in topic 1. Sama je. Okay, alright. So gas stoichiometry involve chemical reaction between reactant that produce gases as product. That means in the equation tu ada involvement of gas. It's either reactant or as product. Okay, alright. So you know that stoichiometry is a law of conservation of mass. Maksudnya mass of the reactant should be the same as mass of the product. Dia conservation of mass. Dia tak ada loss of mass. Okay, alright. So that's aside. We have the mass or volume of reactant, and then we convert that into mole, and then kita relate mole of reactant and mole of product, and then we can calculate for the mass ataupun volume of product. Okay, right. Contoh. Ini soalan pasir. Okay, banyak soalan pasir dekat dalam contoh-contoh topik 4 ni, which is good lah. You will be more exposed to style of exam question for topic 4. Okay, alright. Sodium azide is used in some automobile, airbags, automobile. Okay, the impact of a collision triggers the decomposition of sodium nitrite as follows. So this is an interesting information. Awak tahu tak dalam airbag awak tu dia macam mana dia boleh mengembang secara abrupt macam tu, okay, to protect us from impact of the accident. Okay, so dia pakai sodium azide ni. So dia letak sodium azide ni. So sodium azide ni dia dalam bentuk solid. Okay, so bila ada impact, the impact of a collision triggers the decomposition. Bila ada impact, it triggers the decomposition of this sodium azide. They decompose into sodium and nitrogen. Okay, so production of nitrogen ni secara tiba-tiba, produce quickly, will inflate, mengembangkan the bag between the driver and the windshield and dashboard. So in a way to protect the driver lah. Okay, dia akan mengembang. So dia mengembang tu is because of the production of nitrogen. Because gas saja yang boleh mengembang. Okay, so it cause the inflation of the gas. Inflation of the bag, due to the gas production. Soalan tanya, calculate the volume of nitrogen generated at 80 degrees Celsius with this pressure, at this pressure, by the decomposition of 60 gram of sodium nitrate. Sodium azide. Okay, sodium nitrite. Ini sodium nitrite ni. IDE, N3 minus. This is N3 minus. IOU. Okay, alright. Okay, alright. So dia bagi information on the solid. Dia nak tahu nitrogen punya volume. Okay, first kita kena relate mole of the sodium nitrate, sodium azide dengan mole of nitrogen dulu. When we have that, we can calculate using PV and RT to find the volume. Okay, alright. So convert dulu 60 gram of sodium nitrate, sodium azide ni into mole of sodium azide. And then from there, you relate using the balance equation, okay, with nitrogen. This is what we call stoichiometry. Okay, pakai conversion factor, dimensional analysis, and then we have the mole already here. Kita dah ada mole, cantik lah dekat situ. Soalan nak apa? Soalan nak volume. So to get the volume for the gas, you have to use PV and RT. Please bear in mind, PV and RT is used only for gas. Jangan guna solid kira guna PV and RT. Salah itu salah. You mesti ada connection dulu, baru you nak guna, you cakap. You tak, sebab PV and RT is for gas. Jangan guna untuk solid. Okay? Ya, so dapatlah, siap. Okay, dapat dah. Itu je. So ada banyak example dekat situ. Okay, so this is another example like I have mentioned to you just now. Nampak tak? Okay, cuba baca. For the complete combustion of 7.64 liter of acetylene, okay, measured at the same temperature and pressure. Wow. Nampak tak? Soalan dia bagi hanyalah dalam volume sahaja. And then dia bagi equation. Apa benda pun tak bagi, dia kata same temperature and pressure. Tiba-tiba soalan kata calculate the volume of oxygen. Okay, this is for acetylene. Okay, acetylene which is the reactant. Soalan nak tanya for oxygen. Stoichiometry kena ada kan, betul tak? Tapi as you can see, the information is given in terms of volume. Apa pun dia tak bagi dekat sini. So that's why saya inform tadi awal-awal tu that volume, okay, is also the same as mole. So we can assume that volume is the same as mole. So kita ada the coefficient, kita boleh assume that the coefficient is also the same as volume. Okay, so from equation we know that 5 mole is equal to 2 mole. But in the question we do not have information in terms of mole. Tak ada. Yang kita ada hanyalah liter sahaja. Okay, Okay, therefore we can convert the 5 mole and 2 mole ni that we got from the equation into liter. Okay, so this one we got from the equation. Okay, kita dapat daripada equation and then we can calculate for the volume of oxygen. So this would be your conversion factor, guys. Okay, alright, so this is given in the question, so we can calculate for the volume of oxygen. Okay, so we have checkpoint there, so complete all the checkpoint and then we will discuss it next week. Okay.